Hello everybody and welcome to Unit 1, Section 6. It's going to be on our unique Earth. So what is it exactly that makes Earth unique? And there's a potential pause point if you want, just to try to remember something from our previous lectures. What makes Earth different from all the other planets? First things first, free oxygen in the atmosphere. This is, for all sorts of reasons, very unusual. As of now, the only process we know of that could fill an entire planet's atmosphere with free oxygen is life. You might remember from your chemistry classes that oxygen is a very reactive element. So having it just sitting around in abundance somewhere is kind of an unusual process. This is sort of like going to the middle of a desert and finding an abandoned supermarket there. And you walk in the door and you notice that the whole thing is stocked with fresh food. Well, uh, what this tells you is that there's life. Obviously, somebody or something is there. Whenever we're looking for extraterrestrial life, we're looking for life on other planets, what we're doing is trying to use radiation to probe the atmosphere of those planets, looking for free oxygen. We also have our hydrosphere, we have all three phases of water. Not just liquid water, which we might see on other planets, not just ice, which we might see on other planets, but all three forms, solid, liquid, and gas for water. We also have, of course, all of the life on here. The history of the Earth is, in many ways, inseparable from the history of the life on it. Biosphere is just another thing we have that none of the other planets do. And finally, we have, well, these processes that happen as a result of the hydrosphere interacting with all of the rocks here. Earth weathers in a way that other planets do not. Somewhere like Mars has mountains which are much, much larger than any of the mountains that we have on Earth, in part because there's no weathering there. There's no water, there's nothing that would break the rock down or move it or alter it in any way. And building on this, because we have this weathering, we have the regolith, our term for soil. There's this blanket of loose, fertile material covering the Earth. Again, there is not soil on other planets as far as we know. And finally, the surface of the Earth is constantly changing. Give the example of Mars. Again, Mars is a dead planet. The surface of Mars is not changing over time. The surface of the Earth, however, is in constant motion. And building on this, we talk about the dynamic system of Earth. Just a refresher, uniform in its processes. We use the processes that we see now working backwards in order to figure out what the Earth might have looked like before. Uniformitarianism here, this is a refresher from our second section here. But one phrase that you might want to remember here, the present is the key to the past. If you remember that, you can remember what uniformitarianism is. So these are kind of the processes we're talking about when we talk about a dynamic Earth. Volcanoes, earthquakes, the weathering and abrasion that would have produced this arch here. We can go out and see these happening today, and we know what the Earth of today looks like. So using those two, we can work backwards and have some ideas of what the Earth might have looked like a long time ago. Back to what makes the Earth unique, its plates are moving over time. If we were to go back 100 million years, the continents would not at all be in the same places. Actually, kind of a rule of thumb for this one, the plates of the Earth more or less move at the same rate that your fingernails grow. So there's going to be centimeters per year, or kilometers per million year, whenever we're working in geologic context. GPS, something we have these days, actually allows us to tell the absolute motions of these plates. So not just, these two things are moving apart, but this one is moving this way at this rate, and this thing is moving this way at a different rate. It gives us absolute motions for this, not just for the Earth, but we can actually do this with other bodies in the solar system as well. And of course, by uniformitarianism, we can use these plate motions, combined with our knowledge of where the continents are today, to work backwards and see what the surface of the Earth might have looked like 100 or 200 million years ago. Something which Earth has that none of the other planets do is plate tectonics. There are other bodies in the solar system, other planets which have something which is like tectonics, but none of them quite have Earth's style of plate tectonics. And we'll talk about more on what that means later. But this is our movement and interactions of the large plates of Earth's crust. This is the bulldozer behind all of the changes that we see on Earth. This is the original driver for all of those processes. Plate tectonics is pretty close to a grand unifying theory of how the Earth works. This is the ultimate driver of everything else that makes the Earth alive. And when we talk about these plates on Earth, we can actually break this down. We separate it into parts of it which are ocean, younger, thinner, and more dense, and parts which are continent, older, thicker, and less dense. And actually, this diagram here does a pretty decent job of showing this. So we have ocean here going underneath. It's denser, remember, our lighter continent. And right here, where the two meet, this would be our plate margin. This is where we would expect all of the interesting, exciting things to happen. I'm going to go over briefly our big ideas for this unit. Our main takeaways, if you don't get 100% of everything, that's fine, but these are the most important things that you should take away from these lectures. First, the answer to this question, what is geology? Why is it important? How did the solar system form? What is the order of events? And what are the processes that makes the solar system look the way that it does today? What are the layers of the Earth, and why is it separated into layers? And finally, what does this mean, uniformitarianism?